Hello everyone. So today we will be starting the third lecture of stats. And in the first two lectures, we saw that what is statistics and what are the different types of data, what are the different types of statistics. And we look about the stats from the perspective of how would they ask in PGDBA examination. Sorry, not the examination, but the interview. So in every lecture, I give you two activities or assignment. I hope you are following that. Okay, if you do that, I think that will be enough for your interview preparation. And if you want to prepare more, so you can take the inspiration from those questions, prepare your own question. So I think that will be enough. But considering statistics is not the only subject you have to prepare for the interviews, so you have to keep in mind that other than the stats, there are other angles like HR questions, machine learning based questions. Sometimes they may ask you questions on linear algebra. Having said that, they will be asking those questions if they find that you should be asked those questions. It means they are finding that you are having some relevancy to be asked questions from the legal algebra, and they will be asking in that case. Okay, but it is advisable that you prepare the basics of all these things at least. So in this section today, we'll be studying about the visual description of the data. So when we say the visual description, so it means explaining the data through the visuals. When we say the visuals, it means graphs, charts, or diagrams. Okay. Uh, so to understand what is the importance of the visuals, whatever the text I have written here in this document, if this were to be presented through some charts or diagrams, if there are some analysis, I'm writing those analysis in the form of paragraph or points. In spite of those, if I draw some plots, charts, then they will be more convenient for your brain to process. That is the first thing. Okay. Second thing, it uh, does not means it is easy to for the brain to compute. Okay. And it is easily communicable. Communicable means whatever the chart is trying to say, the other person is understanding the same story. Okay. So the advantage of the visual description is that brain processes it fast. The charts, graphs, the diagram or the pictorial, these approaches are being processed by the brain faster than the text. Okay. Second thing is communication gap is not there. Communication gap means I have to share my analysis with you. And if I'm sharing my analysis in the terms of paragraph points, so you have to comprehend it. So additional level of skills will be used. That is the reading comprehension skill. But what if I present the same information through the charts? So that communication gap, that barrier is removed. Okay. So these are the two advantages. And third thing is storytelling becomes more easier. The narrative becomes more comfortable for the speaker as well to communicate with the audience. So these are the three uh, basic logics which I think are actually uh, driving us to why should we study the visual description of the data. And when we say the description of the data, it means we are describing the data. We are actually using the core principle of the stats only. Only the means is we are using the visual techniques. The visual techniques are multiple. If you are actually into the field of data visualization, okay, a dashboard developer or Power BI developer, table developer, then you must know that it is a different means it is a different domain altogether. There are various job roles which are asking only for the dashboard developer, but a data visualization skills only. Okay, since you are coming into this field of PGDBA, which means business analytics. So uh, no analysis or the no analytics would make sense to the stakeholder or the leadership unless it is means if you are not able to communicate it properly in a very intuitive manner. So it does not matter you build exceptional machine learning model, you build exceptional accuracy, you did everything perfect, but you are not able to communicate the story, then leadership will not be able to get the confidence. Okay, it's good, the research is good, the work is good, but how is it helping our business? Okay, so whenever we talk to the leadership, we have to communicate the story. And whenever the storytelling skill is coming in picture, graphs are always the thing you can never ignore. Okay. So here, I will not be teaching about the data visualization or the storytelling uh, uh, we do in machine learning or the consulting or analytics. I'll be telling you 4 or 5 things which can be asked in the interview. If anything is being asked other than this, then keep the basic principles of storytelling in mind, that the computational effort of the brain has to be reduced. The communication gap between what the narrator is saying, what the audience is listening. That communication gap should not be there. Second thing, storytelling should become more interesting. It should not become very boring narrative. Okay, these 3 things become very means quality checkpoints for visual description. Okay, if I'm explaining the data through the visuals, then these 3 checkpoints are being satisfied. So first thing I'm saying is the line chart. I will not be going into the deeps because interview will be for 15 to 20 minutes. Max to max, it will be for the 25 minutes. Okay, and they will be asking you, say, if they will be asking you to solve any problem or plot any chart, only 1 or 2 questions will be there. Mostly, it will be a kind of interaction, conversation between 4 people. Okay, 3 professors and you. Okay, and every professor will be interacting with you, so you can call it to be interaction of one-on-one. So I will not be going into the maths. They will not be asking maths, and you should be able to communicate your thought. And whenever you have to communicate your thought, you have to speak on the basics only. Okay, don't go too much technical, because there is one professor who is coming from the Calcutta background. Okay, that person will be evaluating more on your clarity of the thought, the clarity of your speech, and the clarity of your logics. Okay, the other professor from the IIT and ISI, uh, they may uh, evaluate you on the basis of your uh, technical angles, whether are you comfortable with the derivations or the maths or something like that. Okay, so the first chart I'll be taking is the line chart. Line chart, as we all have drawn in our life, it means I have to present the information using both the axis, x and y axis, and it will be a kind of line. Line can be increasing, decreasing, constant, okay, anything. So line chart, there is one very important uh, area which we study in regression. Okay, although regression uh, is not exactly a line, but the intuition of the regression becomes comfortable if we look at the two-dimensional uh, regression analysis in an XY chart as a line. Okay, so I will be giving you some briefs about the regression in upcoming lectures. But for now, you can understand that regression is one of the aspects we can understand through lines. Another is histogram, bar chart, pie chart, scatter diagram, and one is the box plot. Scatter diagram and box plot we'll discuss later when we would have studied some more statistical terms. So for now, I'll be speaking broadly about these 4 charts: line chart, histogram, bar chart, pie chart. So this is the kind of summary I created. It is not very exhaustive. It is just very generic. Okay, and it will be enough that you can speak something in the interview. And if anything additional that is being asked, very specific that is being asked, for that just apply your logic. Okay, just visualize the chart and try to have some differentiation between these two. Okay, first is line chart. When we use the line chart, first thing, the type of data. If the data is continuous or it is in a kind of time series, then only you can apply the line chart. If you are having some categorical data, I hope you are able to map things in your mind. If the data is like x and y, if x is 10, y is 5, x is 5, y minus 2, 2, and 3. If the data is continuous on both the axes, in those cases you can apply the line chart. If the data is something like this, if here it is subject, math, 10 marks, physics, quantity, chemistry, 80. Here the one axis is on the categorical side. So here you will not be in a position to on the line chart. Very obvious. You all have studied the coordinate geometry. Both the axis should provide you some continuous number. So if any one of the axis becomes non-continuous, then line chart will not be applicable. It is the first differentiation you can speak. So if the recruiter is asking differentiate between any two charts, if I say differentiate between line chart and the histogram line chart or bar chart, so you can speak the first difference either from the purpose or from the type of data that will be used. So the type of data used in line chart is continuous. In histogram, it has to be continuous numerical data. Bar chart, it has to be categorical data. It is the categorical data. Okay. So the difference, if they ask what is the difference between line chart and histogram, so here both are using the similar type of data. Okay. So the difference will be coming from here, the purpose. Here in the line chart, we show the trends. Trends means either the pattern is on increasing or decreasing way. Okay. This is the trend. And in histogram, we show the frequency distribution, the distribution of the frequency. How many people are having that particular value? Okay. And since data is continuous, so I can also group the ranges. I'm giving you one. I will be giving you one assignment on histogram, line chart, bar chart, and pie chart. You have to plot those charts, and it will be very simple. Okay, you will understand those. Else, you can go to Google and just look at those charts. What is line chart, histogram, bar chart, and pie chart? So line chart will be this, this. It is a time series, something like this. Okay. Histogram will be discussing more about the distribution. Whenever I have to study about the distribution of the continuous variable, okay, so I will be looking at the histogram. Histogram is something like this. Okay, we will be studying more about the histogram when we will study about the distribution functions in the upcoming lectures. Okay, so here in today's session, I will be discussing these charts only from a broader perspective. If you think you need more details, then as the time passes by, as we are coming into the relevant section, we will be discussing them in detail. Here I am just giving you an idea. Bar chart to compare different categories. I am having two categories here. One category is math, another category is physics. I have to compare which one is scoring high. So in this case, which plot will I draw? I'll see, okay, one axis is categorical, another axis is continuous. Okay, it will be going with the bar chart. These are the charts you have studied in the 9th, 10th classes in NCRTs. Okay, or from whatever the board you have studied. So these are not something which is surprising you if I use the term bar chart. Okay. And another thing is the pie chart. The only difference between pie chart and bar chart is pie chart gives you the uh, suppose you are having four categories. So out of total distribution, okay, from those four categories, how much percentage of distribution is being occupied a particular category? If the question is being asked in such a way, then we prefer pie chart. But the drawback of pie chart is when the categories are multiple, because in a single circle, I have to show 33% here, randomly 20%. I'm taking random marks, something X%. This kind of presentation of data, that out of total, this particular category is having 33% presence. This is having 20% weightage. This is having X% weightage. Now, if the number of categories are more, ideally, there is no such strict rule, but ideally, if number of categories are more than four, then I do not prefer to plot a pie chart. I rather will go with the bar chart because pie chart becomes inconvenient to eyes. It does not help us to consume the story in a less computational effort. As we saw, the objective of the chart is to the brain should be able to process the data fast. But if the number of sections are more in the pie chart, so it becomes lesser convenient for us to complete. So we'll be going with the pie chart. So that will be the case where we will not pick the pie chart. Okay. I have given here some few examples. You can look at those. There can be infinite examples, use the internet, just to, or you can leverage your work experience, academic backgrounds to prepare your more personalized. If you have ever worked on your bachelor thesis or master thesis, you can take the help of how had you explained your data to the professors, which kind of analysis, which kind of chart you do. Okay. Now here are some interview questions you can prepare. I'll share this talk with you. Okay, once this talk is with you, you can look at those. Now, statistical description of the data. Here we saw the visual description, and this is not the only visual description. There can be multiple, but I have discussed only which I think can be asked in the interview. Okay, now uh, uh, I will be showing you the charts as well, which are not pasted here now, but I will be showing them when I will share this talk. Okay, or I think that is very obvious. If these charts are not present, this histogram is not present in this doc, you can go to the internet. That is very simple diagram, histogram, bar chart, pie chart. You can go to the internet and search for it. If there is anything such specific for which I think I should provide the image, I'll do that. For example, there's some skewness diagram out there, which I thought that it has to be there, so I have pasted that in this talk. But for the bar chart, pie chart, I thought that you are able to get it. Now coming with the statistical description, we are now describing the data using the stats. We are not using the visuals. So there are two major methods. One is the measures of the central tendency, means understanding the central tendency. Whenever we study the central tendency, we are getting one value which is representing the whole distribution. So that value we call it to be the central tendency. Okay. Whenever we have to describe the data, we have to speak on two things. One, select any central tendency. Central tendency will describe the whole data. Second thing, how the data, how the complete data is being distributed about that central tendency. Means there will be one central tendency, how the data is distributed about the central tendency. If I understand these two things, then I would have a good amount of understanding of the data. Okay, so whenever I have to describe the data statistically, these are the two ways I will be thinking upon. These are not the only two ways, but these are the uh, least two things you should know about the data. Okay, to know it statistically. So let us start with the measures of central tendency. Okay, so we will be studying three measures: uh, arithmetic mean, median, and mode. Arithmetic mean is also called as the average or simply the mean. There is one formula, three. Uh, there is one formula I'm forgetting now. 3 median, uh, mode plus 2 mean, something like this. I'll confirm. I think there is one formula. I have never used it in real life, so I'm not able to remember it. But 3 median equals to mode plus 2 mean. I'm just highlighting it here. Confirm it. Okay, from internet. Okay, because right now I'm getting that this is formula while preparing this doc. That this formula was not coming into my mind, but they can ask this. Sorry for the handwriting. It is becoming little inconvenient for me to write. It is becoming very untidy. That is 3 median equals to mode plus 2 mean. I think formula is this. I studied it in my class 10th. After that, I never used it in my work yet. Mm, just confirm it from the internet and remember it. The recruiter asks, what is the relation between mean, median, and mode? Then you can mention this relation. Okay, just confirm it. The arithmetic mean. Arithmetic mean is simply the mean. It is just the sum of observation divided by the number of observation. This is the most common central tendency we use in daily life. On average, these are the keywords we have been using, okay, since our childhood. Okay, so what is the assumption in the arithmetic mean? there is no such assumption actually, but while while we means without any assumption we can get the data. Means data is the data is continuous. Okay, so I can get the average. The data is quantitative format, I can get the average. Then what is the meaning of assumption? Assumption means if there is a present of extreme outlier, then in that case arithmetic mean does not make sense. It becomes tilted towards that outlier value. Suppose in a city there are 5%. Okay, one person is earning 10,000 rupees, second person is earning 12,000 rupees, third is earning 14,000 rupees, fourth is earning say 8,000 rupees, and fifth person is earning say 10 lakh rupees. If I take the average of these five people, so it will be coming in lakhs. But if you look at the individually, the persons are roughly in the range of 10 to 15. So whenever the extreme outliers are there, so average becomes tilted towards that outlier value. So we assume means we expect that if I'm using the arithmetic mean as a central tendency, then it should not having any outlier. If the outliers are there, then you have to treat those outliers. And the outlier treatment is a particular uh, uh, way to do in data pre-processing by doing machine learning. Okay, so this is the drawback. If the data is having extreme outlier, arithmetic mean will not be of any use. Okay, because the values are not truly representing the whole distribution. Okay, one thing is it is easy to calculate and understood. The objective of using the central tendency is to understand the data, to understand the distribution of the data, and also to understand the others about how are you thinking the data is telling you. Okay, so it is easy to compute, easy to digest. The type of data it requires is here. I have given one example. Okay, and best when data is symmetrically distributed. I think it is the same point which is written here. Whenever the outliers are missing, when the data is not having any outliers, so it will always be symmetrically distributed. Symmetrically distributed means if I go if I go towards the right of the central tendency, okay, and if I go similar distance on the left of that central tendency, I will be observing same behavior of that distribution. That is the symmetry. Okay, if the graph is having symmetry or the distribution is having symmetry, going with the arithmetic mean is means is preferred. Now coming with the weighted mean, if you are coming from an engineering background or your college gives you the CGPA, okay, so that is the classic example of the weighted mean. Weighted means uh, here in that case what happened? I took five people's salary and divided it by five, and I mentioned it at the average salary of five people. But what if I say that the weight of each person is not equal? Okay, and weights will be assigned based on some understanding of the context, the scenario, the business. Okay, if I say that it is least likely that I will be means it will be one in a million that I will be getting a person who is earning more than 10 lakh. So what will I do? I will assign some score here, say 0.001, something like this randomly. Okay. Similarly, I will assign some score to this person, to this person, to this person. So these scores will be kind of weight. Okay. So here, if the weight of one person is W1, another person next to weight is X2. Okay. So I will be writing arithmetic mean as W1 X1 plus W2 X2 divided by W1 plus W2. So it will be the weighted mean. Advantage of weighting mean is that many of the time I will find that all the observations which are being recorded are actually not of equal importance every time. Some are more important, some are less important. So in that case, I'm assigning a weight here. If you look into your PGDBA selection process, you would have identified that they are taking your 12 percentage only certain percentage level. They are taking only a few 7 to 8% of your work at 7 to 8% of your 12, but they are giving weight to 45% to written exam, 40% to the interview. So it means they are putting more weights on the scores achieved in the written and the interview rather than your 12th score or the work test. Okay, so in this way you can understand that in the analysis it will happen if the analysis is realistic that all the variables, all the inputs are not of equal importance. Okay, so in that case, what will happen? You will assign some weights. Again, it can be uh, uh, means it can become unreliable if the outlier is here. Also, that outlier can be treated, but if I don't treat it, if I put a weight, something like that, it is diminishing the effect of outlier, that can also be done. But if the weight means outlier is extreme high, so in that case, I will not again prefer to go with the mean. Now median. Median, before going with the median, I think I should explain you the quartile. So after discussing the quartile, I will be coming to the median again. Okay, median is nothing but the 50th percentile. I will come here again. I am skipping it for now. Now coming to the board, the value that appears most. Okay, out of 100 observation, uh, if 70 people likes ice cream, 30 people likes say randomly chocolate. So what is the mode? Mode will be this ice cream. Very basic thing. All you have done within this thing. Okay. So what kind of data would it require? So only thing you need to prepare is if they ask you to differentiate between two or three arithmetic mean, you can first thing you can speak on the type of data they would require, their advantage, their disadvantage. If you speak these 3 points, it will be enough. You will not be getting more than this much time because you have to speak at the moment. You have to think at the moment. So I think you will not be getting more than 3 points at that moment. Okay. And if you want to do something additional, just prepare one example from your real life. Then you can just try to support these pros and cons. Simple. So these are the 4 things you need to remember. No need to go into too much theory. No need to read too much academic text on this. Okay, too much academic text says these are the properties of arithmetic mean, solving numericals. That is not required. Even if they ask you to solve the numerical in the examination, they are truly not evaluating your the computational skills. They are evaluating your logical reasoning skills. And whenever the recruiter is asking you to solve any numerical on a piece of paper, you are not ideally required to take a piece of paper and solve it. You first have to structure the problem, communicate how are you thinking it has to be solved. These are the steps you are thinking that you will follow. First communicate, then solve a little, then explain it. If you do it, so it becomes a conversation. That is not a written examination. Okay. And in this process, even if you are doing some mistake, there will be two cases. Either the recruiter will correct you somewhere, okay, do this way or that way. Okay. Second thing is, in between the recruiter will say, okay, fine, I understood your approach. Now let's proceed forward. So these two cases can happen. Okay, but if you were to solving it like a numerical problem and then you are just discussing the final answer, so in that case you lost a lot of opportunities to discuss things. You lost the opportunity to get it corrected if you were making some mistake. Okay, so the intent of me is to make you understand that asking these questions, that question in the interview is actually about uh, uh, getting you evaluated from a perspective of a business person. Okay, now coming with the mode. Mode is done. One statement, fancy statement I put it here. Mean balances values, weighted means reject important, respects importance. Median protects from extremes. Mode tells what is in common. Just fancy thing, I liked it, I put it here. But the thing is, you have to keep these columns in mind. Now, I just mentioned one thing, symmetry. Okay, so okay, before explaining it, I should explain the median. Okay, I'll come here after explaining the median. Now coming to the measures of dispersion. In measures of dispersion, I will be explaining first quantile, then I will be going to the median, and then I will come again to it. Quantile means if just sort the data in increasing order, okay, and then divide the data into equal parts, n equal parts. Suppose I sort the data first. First, we have to sort the data. Without sorting, this quantile cannot be done. Quantile means dividing the data into equal parts after sorting. If I'm having 100 observations, if I sort all of them in increasing or decreasing, whatever the order, and I divide the whole data in 10 parts. Okay. If I so that will become decile. If I divide the whole data in say 4 parts, so it will become quartile. Okay, if I divide the whole data in 100 equal parts, so it will become percentile. Percentile, same thing you get in the set. Okay, so this is the quantile. If I divide the data in two equal parts, say this part and this part, so first division will be at 50 percentile, second will be at 100. Okay, if you divide it in say 4 parts, so first division will be at 25th, then 50, then 75th percentile, then 100 percentile. Okay, if you are dividing it in 10 parts, then each decile will be there. Okay, so you can divide it into n number of parts as you wish, but these are the standards. Dividing it in 2 parts, 4 parts, and 100 parts. In 100 parts, you have seen the application in your CAT examination. Percentile scores. Okay, in dividing it in 2 parts, getting the median, we see it in the 50 percentile median. Okay, that is the example of the 50 percentile. And this dividing the data in 4 parts. So you are getting the data in 4 parts. One data is from 0 to 5 percentile, then 26 to 50, 51 to 75, 76 to 100. Okay, so these are the 4 parts. So we will be discussing it in the box plot transformation or box plot. There's a kind of plot that is a box plot that gives the 5-point summary about the data. Okay, so we will be discussing it later. So these are the quantiles you study. So the type of data, can you guess what kind of data will it require? Okay, so that is the homework to you to understand it. Simply it is written quantitative, ordinary also for some use cases. What could be the use cases where you will be applying this? You just have to divide the data in equal parts after sorting it. Okay, it helps understand the distribution beyond the center. Okay, it can be unstable in small data sets. Okay, these are the examples. Data should be ordered meaningfully. Now coming to this median. Median is actually a quantile, means data is divided into 2 parts. So the division is actually happening at 50th percentile. It means 50% of the data is lying on the right side, 50% of the data is lying on the left side. It does not matter what is the value of the data on the left and right. It only divide the ranks, divide the position. Quantile divides the position of the data. So when I say this is the 50th percentile of the data, it means data is, I'm not sure about the values. I'm sure that 50% of the data is lying right of this part and the left of this part. So that is the thing. So it means if this distribution is actually not accounting the values of the data, it is only accounting the position of the data. So can I say that it is not getting affected by the outlier? Suppose if in this example, if I have to rank these people, so I will be ranking 10K as rank 1, 12K person as rank 2, 14K person as rank 3, and third person if I take 18K as rank 4, and 1 lakh as rank 5. If I do the median will be here, the 14K. Okay, how did I do? 1, 2, 3, 4, 5. I got this 3 as the median because 50% of the data is lying on the left, 50% lying on the right. So 14K is the position where data is divided into 2 parts. Now it does not matter whatever the value of 14K is there. Suppose if in spite of 10K, I replace it with 8K. Again, its rank would have been same. So if in spite of 1 lakh, I make it say 100 lakhs for 1 crore. Okay, again the rank will be 5. So it means changing the outlier values is not affecting my median. So median is stable with the outlier. So that is the advantage. Okay, that is the relative advantage compared to arithmetic mean. Okay, not affected by extreme values, good for skewed distribution. Okay, now mode we have studied. Now come to this. In symmetric distribution, what happens? Mean, median, and mode, everything is same. This is the symmetric distribution. Now what happens? Suppose if I add one outlier value here, I add one outlier value. Okay, this is the symmetric distribution. Now I added one outlier value. Outlier means extremely heavy value. If I added that value here on the right side, here, what will happen? The mean will shift towards the outlier. The arithmetic mean will always shift towards the outlier. So mean will get shift towards the right. Okay, if the outlier is added towards the right side. And median, since the median is not getting affected by the outlier, so median will be at the same place. Median will remain here. Okay, mean will shift towards the right and mode will shift towards the left. Okay, and if I add the outlier on the left, so what will happen? Mean will shift, median will be at the same place. Mean will shift towards left, towards the outlier, and mode will shift towards the right. Okay, so in case of it is called a negatively skewed, it is called a positively skewed. Outlier is on the negative side, means on with respect to the median. If outlier is on the negative side, it is a negatively skewed. It is on the positive side. Negative means left side. Positively skewed means if on the right side I am adding outlier, so it will be positively skewed. Now skewness refers to the tendency of distribution, tail off to the right or left. Tail off means just getting some this kind of tail. Okay. This is income distribution tends to be positively skewed. Why? Because there is no lower limit of zero. Means income. If I have to draw the income distribution, so I will not be plotting any value on this negative x-axis because there can be no negative income, but there is no upper limit on this side. People will be earning in millions, billions, no upper cap. But on the lower cap, it will always be zero. There will be no income less than zero. Okay. So it means this will be a skewed distribution. Which one? Positively skewed because on the right side of the median, I'm getting the outlier. Okay, and this will identify it. Now measures of dispersion. Okay, I'll do it quickly. Then we'll wrap up this lecture. So we have understood the quantiles and now range. Range means difference between maximum and minimum. Difference. Okay, it is very simple, but the drawback is again it is very sensitive to the outlier. Whenever I'm accounting the outlier in the calculation, all those metrics will always be affected by the outlier. So that is the thing you have to keep in mind. Okay, it will be affected and range we generally use when the data set is uh, small. Okay, in those cases we are comfortable using the ranges and data should not have any outliers. Okay, for the large data sets, range becomes, I mean, range does not make any sense for the large data set. Okay, data must be ordered numerically and it is very easy to calculate for the simple computation, simple analysis. We use it. Quantiles we have studied, and we will be studying percentile, quartile, and this median in majority of the cases. Now, mean absolute deviation, variance, and standard deviation. Variance and standard deviation. Okay, I will be discussing them in detail because their these will be the most used metric to understand the variance or variability of the data. Okay, population variance, population standard deviation, sample variance, sample standard deviation. These are the four things you should keep in mind. I think this much text will not be enough. I will go into deep of it. In the upcoming lecture, I have to explain the details of the variance and standard deviation. I will be going with the formulas of these two as well. They will not be asking you the formula, but you have, if you understand the formula, then you will understand the logics. Okay. Now mean absolute deviation. So it is the average of the absolute differences between each data point and the mean. Suppose these are the different points x1, x2, x3, x4. Suppose this point is x is the mean. So what is the difference from x2 to x mean? Just take the difference and take the absolute value. Means if the difference is negative, x2 minus x mean is negative. So just take the positive value. So that is the absolute deviation from the mean. Okay, so it is robust against extreme outliers compared to variance. Compared to variance, it is fine, but problem is we usually avoid those metrics where the modulus is used to get the absolute value. Use the modulus. Why? Because in case of machine learning, we'll discuss it later. Then we discuss about the that in case of machine learning, it becomes difficult to converge or get global minimum point in case of models. Okay, we try to avoid this kind of variability metric. So most used metrics will be quantized, variance, and standard deviation. We will be studying variance and standard deviation in details later. For now, they can ask, means I'm not expecting they will be asking about the mean absolute deviation. Just remember what kind of data will it require, what are the positive and negative. This much is mean. Okay, so this is for today. And in this session, I have accounted few interview problems. Just to go through it. What is the difference between arithmetic mean and weighted mean? Okay, and if I add a constant to all values, how does the mean change? Okay, and these are very simple use cases. If you try to solve it by taking example by yourself, then you will be able to understand it. But remember, these questions are expected to be asked in the interview, not in the written examination. So you should be able to explain it in a verbal format. Okay, what happens to the weighted mean if all weights are equal? How GPA is a weighted mean? Okay. Why is the median preferred income data? Can you think of a real life scenario where median is misleading? Okay. Can a data set have more than one mode? Is mode always useful in continuous data? For this means I have added 2 or 3 problems for each section just to inspire you how the questions can be asked. If you want more questions, just take the help of the internet, and I think looking at these questions will give you an idea that what kind of study you have to do it. Okay, you are not required to study it like a statistician. You have to study it like uh, uh, someone who needs to use this data to generate some businesses insights or create some policy. Okay. So this is for today, and for those topics where I have mentioned in the talk but did not discuss, that is because that will be used in the later case. Okay. So this is for today. Thank you. This talk will be shared with you. So in case of any doubt, you can always come to me. Thank you.